I think you should know this one.
Was that doing
No. I don't remember. Yeah. Still going.
Oh, did we switch it? Did you remember? Because I did not. You are great.
This guy's on there.
What? Yes. Talk louder and then I can answer your question. I just can't quite hear you. Okay. Yeah. Yep. Well, if this one you needed to because there was an X in it, but if there was no like X or Y, you just look at it.
What did you plug into?
-4/3, because that's where I was looking.
Gotcha. Thank you.
Everyone okay? Okay, if your big D formula comes out to be 0, you did it wrong. Can I be clear? I'm hoping that's really obvious. Well, maybe obvious now. Anderson.
So what would they, for a question, what would they ask? Like find the critical points and tell what it's a max or min, or?
They usually say find the relative extrema, or find, classify the extrema. So
we
something
wouldn't be
about
looking
extrema.
for a saddle point, we'd be looking for like the max or min. Or?
Saddle point is an extrema. Okay. Now that I have this, you guys ready? Okay, this is the one we want to maximize, so it goes first. Am I still writing large enough? And then this is my constraint, so it goes next. I think this is right. I'm pretty sure it's right.
Yes. Yes.
I mean, I hope I remember the problem correctly. I was like, you don't remember the problem. At least I hope not. Okay, so I'm going to take the derivative of this with respect to x, with respect to y, and with respect to z. I never do it with respect to lambda, because if I do it with respect to lambda, I just get my constraint back, and I see no point. I already have my constraint. Okay, f of x is equal to y squared z cubed minus lambda, and the derivative of that with respect to x is 3. The derivative with respect to y is 2xy z cubed minus lambda times 2. The derivative with respect to z is 3xy squared z squared minus lambda times 1. Okay, so first thing I do is I take my partial derivatives. The next thing I do is I solve for lambda. It's way easier to solve for lambda and set them equal to each other than trying to set equal to each other and manipulate it so that it would work. Does that make sense? Okay, so if I solve this one for lambda, I would have lambda equals y squared z cubed over 3. This one would give me lambda equals x y z cubed. This one would give me 3x y squared z squared. Yes?
Second lambda divided by 2.
What?
Just
2?
Oh,
2?
2, 2. Okay, never mind.
No, it's okay. I appreciate people helping me. We okay so far?
Yep.
Oof, I think we're gonna make it. I think we're gonna make it to chapter 10 for a whole hour. That's awesome. Okay, so now I'm gonna do, I always do these two, and then these two. I only do 2 at a time, otherwise I get confused. Equal to each other. So I'm gonna do the top 2 first. Y squared z cubed over 3 is equal to x y z cubed. First thing I do, I don't like fractions. So I'm going to multiply by whatever the bottom of the fraction is to both sides. Next thing I do, I'm going to just rewrite it one more time so that I don't have a big mess and you all, I would get confused, so I prefer not to confuse myself or you. Okay, I'm going to cancel out my z's because they're the exact same. I have z cubes on both sides. I have a y on both sides. So I'm left with y equals 3x. Yep, this is right. Just saying. Yes?
And when you do that, when you divide like both sides by a variable, it doesn't mean that that variable equals like anything, like 0.
Actually, it does. If I divide both sides by x, z cubed, technically I'm supposed to say z cubed equals 0, which would give me z equals 0. However, we want to maximize this product, right? I've never seen a lambda problem where you can't just cancel stuff out on both sides without it working. Does that make sense? Is that okay? Okay. So now that I have that, we're going to set the next two equations equal. Okay, who's lost? Who wants me to pause for a second so you can catch up? Okay. I'm going to just keep going. I'm going to do these two. X, y, z cubed equals 3xy squared z squared. So first things first, I can cancel an x. Next, I can cancel a y. Next, I can cancel two z's. So I get z equals 3y.
Algebra is becoming so easy.
I'm sorry, say again? Oh, you're signing your shot. That's fine. Okay. Okay, now that I have that, I'm going to go one step further. I want everything in terms of x, just for the reason that then I won't have any fractions. So y is equal to 3x. I want z in terms of x. So if z equals 3y, and I know that y is equal to 3x, I get z equals 9x. You guys with me? Beautiful. Okay. Did I already guys tell you guys that Monday is going to be question answer?
Yes.
Great. Beautiful. So then I have z equals 9x. Now I go back to my constraint equation. 3x plus 2, y I'm going to say is 3x, plus z is 9x, is equal to 36. So I get 3x plus 6x plus 9x is equal to 36. So I get 18x equals 36, so x equals 2, y equals 6, and z equals 18, which I'm going to write down. So then I get, if x equals 2, that means y equals 6, which means z equals 18. However, they're not going to give you those numbers. You want to know why they're not going to give you x, y, and z? Because if they gave them to you, you could just plug them into that equation and see which one multiplies to the biggest. Do you see what I'm saying? That's why they don't give it to you. So we need to multiply x, y squared, z cubed. I have no idea what that equals. Anyone?
4199.
I'm just plugging x, y, and z into that.
Oh.
Everyone okay? No, they're not going to give you x, y, z equals. You have to solve for it, and then you have to put it into that equation. And then they'll give you those answers. Does anyone have, yeah?
Quick question. So you took the z equals 3y and you plugged it into which one?
I didn't. I took z equals 3y, and then instead of y, I plugged in 3x,
Okay.
and got 9x.
Oh, gotcha.
And then I took all of these equals and put them into my subject to get what x equals, and then I just plugged x into this and this to get 6 and 18. And then once I had those, I need to do this, and I don't know what that equals. 4, just say the numbers, 4, 1. Beautiful. I think it might be good to know that one. Okay, let's do 9, 6. Wyckoff said that there were some bound switching ones. I'm going to start with the non-bound switching one and then do the bound switching one I think you should know. We're going to still be on this board, don't stress. Do number 49 and number 50 from 9.6. If you do those, you'll have done the balance between ones you'll see on the test. Number 49, number 50. I don't know how to be more direct.